Hello, everyone. Hi, my name is Luba. I hope you can hear me well. Yeah, nice to see you today on our technical webinar. And I want to say that this event is powered by Intellias, technology company with international clients, 14 delivery centers across the globe, over 3K people on the board, and a lot of open vacancies. So I will share the link to our career website and feel free to check some job opportunities. Okay, so let's move on. And I want to introduce our speaker, Stanislav Holovachuk, Principal Java Engineer at Intellias. He will be sharing today his experience with you. So feel free to write your questions in the chat and we will answer them during our Q&A session at the end of the speech. Stanislav, I'm sorry. Nice to see you. And the floor is yours.
Yeah, thank you for introduction. Hello everyone, and thank you for coming today. It's an honor for me to present my topic to you. And our topic for today is ensuring code quality and architectural integrity of modern Java application with ArchUnit library. For the next 40 minutes, I will try to convince you that you need ArchUnit in your projects, and after that, as Luba said, we will have Q&A. So we will follow the agenda. We will start from some introduction, then we talk about benefits of ArchUnit, then we jump to some code examples, demos. After that, we sum up and make some conclusion. But before we start, let's do a small offset. I ask you to look at the screenshots provided, and I hope it will give you some first impression about what we will talk today. Here are two screenshots basically of same tests doing same thing. Both are ArchUnit tests, but they are just implemented in different way. First one is using JUnit test annotation, and basically it follows the given when then structure where the given is packages, the rule is your invocation, and the rule check is the assertion. The same can be implemented in different way, more ArchUnit way, where you specify the annotation, analyze classes, which points ArchUnit where he should scan the classes to get the metadata of your classes, methods, variables, everything. And then you have archtest annotation, which annotates a constant, which defines basically the same rule, saying that services should contain service word in their name. Yeah, now that you have some first impression, we can proceed. And what is ArchUnit? It's simply a Java testing library, same as JUnit, but instead of checking what your code does, it checks how your code does things. Generally, ArchUnit is designed to test and enforce architectural rules in your code base. It allows you to define architectural constraints, and then it automatically checks that your project code base adheres these constraints, and it allows to ensure some consistency in your project and catch some architectural violations in the development process very early. With ArchUnit, you can define some custom rules. You can easily integrate it with JUnit and other testing frameworks. And of course, the main feature, you will maintain the architectural integrity of your project. When talking about history of ArchUnit, it was developed in order to address some gap in quality, in architectural quality enforcing, and it was developed by TNG technology. It is already 6 years old, and the current version, as you see, is 1.3. Now let's talk why we need ArchUnit, and the first reason why we need it is architectural integrity. ArchUnit ensures that the architecture follows design principles and constraints defined by the team. It also helps to prevent the introduction of architectural anti-patterns. Second reason is consistency. ArchUnit maintains consistent structure in the code base, making it easier to understand, maintain, and extend. Also, it facilitates collaboration among team members by ensuring that everyone adheres to same architectural guidelines. It is useful for newcomers, for example, when people join your project and they don't know yet how you write code there, what are the rules. You can enforce it, and they will not be able to violate anything. And of course, it also a secondary benefit, you will have less discussions on code review about architecture of your code and so on. Third reason why we need ArchUnit is early detection. ArchUnit catches architectural violations early in the development lifecycle. And as everybody knows, the cost of mistake on the early stage is much less than when it goes further. Now that we discussed why we should use ArchUnit, let's talk about real benefits which it brings. And the first benefit is automated checks. Automated checks are provided by ArchUnit while it automates enforcement of architectural rules. It reduces, as I said before, efforts to manual code reviews because it's already done by ArchUnit. And also it provides some mechanism of safety net that ensures adherence to all defined architectural constraints. Second benefit is integration. ArchUnit seamlessly integrates with popular build tools like Maven Gradle, and it makes it really easy to incorporate into existing projects. Regarding CI/CD, if you already have unit tests on your project, and I bet you already have it, then it is just zero effort. It will be executed together with unit tests. The third benefit is customization. ArchUnit allows developers to define really specific custom architectural rules, which we will cover later in our examples and demo section. And also ArchUnit supports a wide range of architectural constraints out of the box, which you can just import. It can be some constraints about package dependencies, layer interactions, and all this is provided by the reflection mechanism. So the only limitation is your imagination here. The fourth benefit is self-documentation. As usually, tests are serving some live documentation, some code documentation on projects, and ArchUnit is not an exception in that. New team members can just check the rules or even read their names of the rules, and it will be enough to understand what they should and what they shouldn't do in your code base. Now, not yet a demo, but some examples. Let's check how we can set up ArchUnit. So first, you add the dependency, of course, in the Maven, for example. Then you write simple rule, and as we already discussed at the start, it follows some basic structure. You provide the classes to analyze. It basically your package usually, or of course you can provide the specific class name separately. Then you annotate your constant, and then you define the rule. For example, this rule is targeted to fields. You see there's a fields above the number 3 on the screen, and that is a target. And then you provide some conditions to filter. You filter that fields having row type logger, and then you write the assertion. So they should be private, they should be static, they should be final. And in because, you just provide the message. It is optional, but if you provide it and test fails, you will see the assertion error at the bottom of the slide. It is saying basically that rule was violated, and it also points to place where it was violated. One basic rule example is the test that is checking that there are no cyclic dependencies between your slices. We already saw examples, previous example, where selector was fields. At the start of these presentations, we saw selector of classes, and now there is selector slices. Slices is more specific thing. It is constructed with the pattern you see on in the list. Number 1, we have slices matching my up star. So in this concrete test application, we have 4 slices. It is order, customer, user, and authorization. And in our assert, we just say that they should be free of cycles. It means that order should not depend on customer, and customer should not depend on order. Another basic, even more basic example is a resource rule test, which is checking that every endpoint in your Java EE resource is protected with roles allowed annotation. By the way, we use this rule on our project. It is quite useful. The structure is the same. You declare the classes to scan with analyze classes. You create the arc test, and in constant, you say that given is methods, because it is usually endpoints in resource or controller or something. And we filter these methods by being public and being declared in class that lives inside resources package. It can be done in different way, of course. We can say that classes having name ending with resource. That will also work for some projects. And then our assertion is that such classes, such methods should be annotated with security annotation roles allowed. And now let's go to the very, very basics, where you don't even write any code, but you want to use some simple ArchUnit rules. You can just import some of them from which are predefined, coming from ArchUnit library. Some rules like no classes should access standard streams, or throw generic exceptions, or don't use Java util logging. So basically, such rules I think resemble something from PMD and Checkstyle, but it is configured, in my opinion, much more easy with Java code, not with XML, and so on. And comparing the ArchUnit with quality tools, we can highlight such things. First of all, ArchUnit is just different. I'm not sure we can say that it is quality tool, but still it sometimes it serves the purpose of making the code clearer, cleaner, and better. So let's compare. In terms of code quality and bug detection, we can say that while such tools as PMD and spot bugs are trying to identify potential bugs in your code base, and while SonarQube is more powerful tool, of course, which provides some comprehensive code quality management, ArchUnit is different. It ensures only architectural integrity, but indirectly, it also enhances code quality. In terms of setup and integration, if anyone has ever set up pre-commit hooks, I think you will agree that it is not so easy as writing unit test. In terms of SonarQube, it is also requiring complex setup because it requires its web server, and of course it is resource intensive. With ArchUnit, it is just integrated as usual unit test as part of your CI/CD. So I can say that integration of ArchUnit is zero effort in your project. And in terms of customization and extensibility, while commit hooks are customizable to run various checks, but in my practice, they are not often adjusted. They are just set up and at the start of project, and then no one usually touches it. With Checkstyle, yeah, you can configure XML as you want, but who likes to do that? And with ArchUnit, you just write Java code, and it is really flexible, which you will see next. Yeah, soon we will start from this demo. I will share you some code from IDE, but before that, I will ask a question. Which quality tools allows you to do this? This test that you see on the slide is checking the domain model dependencies. If you check the signature of this test, there is classes as our target. We also filter it by classes that reside in domain package and its sub-packages. For that, we have some layer enum. I think at this point, I can already start sharing my IDE because this test is there. We have, as I said, the enum where we defined 4 layers: entity, Java persistence, and Lombok. Basically, maybe layer is not the best name for it, but anyway, for our demo purpose, it's okay. Here we say that classes from domain should depend only on these 4 sources, let's say. And when we run our test, we will have a fail. And the fail is basically here. One entity is okay. It is entity that uses only Lombok, persistence, and Java. And entity not okay, which is pointed in the message, it is here. It is using some stub service. And why we have two violations here? It is because it complains about every method. It complains about do something method and get instance method. Probably can be optimized, but leave it for later. There is, by the way, our stop service, just a file from some service package that is enough to violate our rule. Of course, you don't want to use services inside entity, I hope. And yeah, now let's take a look on one more domain architecture test, which is simpler. Here we select classes from this package, domain architecture test.test1, and we filter these classes by being annotated with entity class, and our assert is that they should reside in package entity. This syntax is like wildcard. And also we provide a message. Let's see what it does. What will be the result of our test, knowing that one entity is indeed located inside entity package, while another one is outside. It's just in test one. And yeah, in our error log, we have message architecture violation in class entity not okay. Yeah, that was example about domain architecture rules. And there is one more interesting one, I think, because it uses a bit more advanced selector. Previously, we used classes, methods, slices. This one is using layered architecture as a target. And here we can define layers. Basically, we defined 4 layers here, which follows some basic Spring application. It is config, resources, services, repositories. And next we do the rule. We say that config layer should not be accessed by anyone. For example, you can't access config from repository. However, some people do that in order to get some constant and so on, which is a violation. Then we say that the resources may only be accessed by config because they can be declared here. Services are declared in config and invoked in resources usually, and repositories can be also defined in config, declared in config, and used in services. That will ensure that layered architecture is respected on your project. Quite simple test, only 10 lines, but that's it. Now let's move to more specific rules. And this rule that you see on the screen is completable future with executor test. Here, we start from the green mark 1. We see that our analyze classes is a bit different than in previous examples. Our target packages are not only our code from our project, which is org example completable future test, but also Java util concurrent. We do that because our assertion is made on completable future class, and we need to provide ArchUnit access to this Java util concurrent, so it scans it and has metadata extracted from this. Our rule is only 4 lines, but actually the actual assertion is separated to private arc condition method only be called with executor. And what is the point of this test? It is also the real world example from one of my projects. At some point, we decided that we want to use supply async method from the executor service only in its overloaded definition with second param. Sorry, I did a mistake. I said executor service, but it's different. Supply async is method of completable future, but it has executor service as its second param. And here we do the test. We select methods from completable future class. We filter them by supply async method, and our assertion is that it should be called with executor as second param. Here is our check. We get calls of supply async method. We receive a collection. Then we filter out the self calls. It means we don't want to check how supply async was invoked from completable future class. Then we filter methods where we don't have executor as parameter, and if there are if any element left, we trigger the error, and that is also in our demo project. It is here the same test that you just saw on a slide, and when I run it, it will fail because, as usually, I have one success case and one negative case. Here is our source code. One class is okay. It is using the completable future supply async with second parameter executor service. And not okay is actually using the definition of supply async with one parameter. Let's fix it. Let's add executor service here as well and restart our test. Let's see what it shows. Yeah, now both tests. Now the test passed for both classes. That's it about completable future. Let's move to the next. The further, the more complex. This one is the last, so please be patient. This one is quite long, but it is also very specific. I will better open the IDE because it is better to see the code zoomed. Here we have our test. It is ensuring that external resources calls will be surrounded by try-catch web application exception. Basically, the rule, as always, is quite simple. It has only selector methods filtered by classes having name resource. It is Java EE resource. And yeah, we also say that they should not be private because we are checking public ones. And yeah, here is our condition. We say that it should only be called with try-catch web application exception. Here we have Java method and some events with which we use to assert the failure. Here we do what? First, we have an if. We check that method was invoked at least once. Yeah, quite simple method. No point in discussing it. Also, we check that it is invoked by our service. Yeah. Okay. We do some logging just for demo purpose. It is system out. And then we iterate on invokers of this method. Here, with ArchUnit, we are able to get the try-catch blocks surrounding this invocation. Since there can be nested try-catch inside try-catch inside try-catch, ArchUnit returns iterator for that. And then we are checking that if at least one good variable name, I agree, but it is demo. At least one try-catch block surrounds this method. We get it, and if it doesn't handle web application exception, actually it's better to define something like that and get name, but it is demo project, so I use simple constant here. Yeah, in that case, we assert that rule is violated. We also print some beautiful message for that. Now let's run it and see what happens. Yeah, we have violation. Methods are declared in resource class, and it should be surrounded with the application exception. It was violated. Let's see where it was violated. Here I prepared some REST resource stub, which has some post, which is actually doing almost nothing. And here's the class which violates our rule. Yeah, there is class not okay, which uses post method of third-party resource without try catch surrounding. And this class is doing the good thing. It is catching the web application exception. Just to fix it and show you that it can be fixed, it will not be triggered on the correct one. Yeah, our test is green now. Let's return how it was and go back to the presentation. By the way, this try catch blocks was introduced in version 1.0 of ArchUnit, so just a sign that library is continuously improved. Now let's talk about some real-world application experience. When we first tried to introduce ArchUnit in one of our services, which was actually not so dead legacy, it was around 3 years old, and we implemented some rules, we took some rules from ArchUnit library, we imported something, and yeah, we did a check, we got such result. Half of them were violated. And what we learned? We learned that we should not give much freedom to people. It is better that on the initializing of repository, you will have some basic ArchUnit tests, like really basic ones about dependencies between services and other layers and so on. Something about generic exception, for example, if you don't already have it in your PFD configuration and so on. If you will have it from the scratch, you will be sure it will not be violated, and you will not need to spend in future efforts for fixing this technical debt. You will also don't need to convince your management that your architecture is not so good and you need some extra budget to fix that. Now, if you are interested in performance of ArchUnit tests, you see the screen. Here, I implemented some basic test, which is doing what I don't even remember. It is checking that services, classes that live inside services package should be annotated with Spring Service Annotation. And here we use GMH library for benchmarking the performance. We test the time. And as you see, it is really fast. So don't be afraid that ArchUnit will slow down the performance or deployment or startup or local development. It is as fast as unit test can be. So that's about performance. And if you are interested how popular is it, I have checked website their stack, and here is our table. As we see, ArchUnit is used by such popular companies as MasterCard, Playtech, Santander, and Fiserv, and many others that you probably know. That's just a good sign. And to sum up, we can say that ArchUnit is the first tool that allows extensive architectural check enforcement, not something simple like checking that generic exception will not be thrown or something. It is much more advanced. It is as advanced as you want it to be. It has also very low entry threshold because everyone who knows how to write code, how to write JUnit tests, can write ArchUnit rules. Also, it is good that these rules are written by devs. You don't need any extra knowledge, any DevOps knowledge or anything. You just write the code as simple unit test. Also, it supports JUnit, so it is a good thing that you can just integrate it in your existing projects easily. And yeah, you can implement really specific checks. As you saw, it is, I can say it's almost not limited. If you wanna enforce really specific cases, really specific things, then feel free to do it. The only thing you should consider is your efforts. Also, very nice thing that it can be debugged. So if something is wrong and you can't understand why, you, instead of going to Stack Overflow, you can just enable debug and see real-time variables and check what's wrong. Maybe some selector was has selected something wrong, or vice versa, haven't picked up what's needed, and you will see it. Also, ArchUnit simplifies code reviews. You will not need to spend time negotiation with your teammates about where you should put this class in this package or that package, because ArchUnit already decided that. And yeah, you cannot violate it. And what is also good, that it is easily integrated even in old projects. The cost of refactoring the old projects is a different topic, but integrated, it is really easy. Regarding references that I can share, I can admit that ArchUnit has really good documentation. Also, you can check their GitHub, Java docs, and also I left the reference to author. And that's probably it. As I promised, 40 minutes for our presentation. And now your question. I already see that we have something in chat.
Yeah, thank you so much, Stanislav. It was a great session, and I've sent you quite a few questions, so we can start from the beginning. I guess you covered already a few of them, but anyways, we can proceed.
Okay, the first question is really good. Does it have any support for microservices environment? Someone has to go and place ArchUnit test cases in each microservice code base. Answer is it depends how you configure it. For addressing the need of copying tests to each repository, I don't think it is optimal solution. And what I can propose here is having some separate library, some separate jar that you will share across all your microservices. You can just create a project, name it somehow like ArchUnit support for my project, and there you define some rules. And then you only connect this dependency in your Gradle or Maven project, and you import it. You decide which rules to execute, which rules to not execute, and that's probably it. Also, an option can be setup of initial artifact. On most of the projects, initial artifact is set up with some script, for example, yeah, that creates some basic structure, some classes, some files like gitignore, like readme, maybe something for Kubernetes and so on. And the same way, you can configure it to have some very basic ArchUnit rules. But actually, sharing the library, the dependency between microservices is a good option. Second question is, would be nice if it can be centrally managed. Okay, it is continuation of previous question. Okay, we have a question from Vlad. Hi, what are the limitations of ArchUnit? In which scenarios this tool is ineffective? In my practice, I thought that I faced a limitation when I was trying to implement the test which was there about checking which exception is catched inside try catch block. And finally, it appeared that I only needed to update the version because recently the try catch block was added. I'm sure that there are some use cases where you will not be able to cover something specific. But actually, ArchUnit is providing very extensive instruments for that. And in my experience, I remember I needed to check that invocation of some service is made inside each method of some class. And it was quite easy to implement until lambdas appeared. And then I needed to check that this class is invoked from this another class or from lambda inside this class. It was a bit complex, but eventually it was solved. So in my experience, I am facing challenges with that, but they can be resolved usually. And also the support of this library is ongoing. New features are being added, so hopefully such limitations will be resolved by the provider. Next question is from Maya. What strategies would you recommend for introducing and enforcing ArchUnit rules in a legacy project? Well, in a legacy project, it depends. It depends actually on your budget and the time that you are ready to spend. Because basically, the only measurement is the quantity of tests and the compromises that you will leave. Because in legacy, sometimes we all know it can be difficult. It can be difficult to resolve some anti-patterns that are living there for too long. They became the part of project. And if it requires moving classes a lot and renaming everything and changing the structure, of course, it will be complex on code review, because no one will want to review a PR where 10,000s of lines were changed. So on the legacy project, I think it is better to go iteratively. So you start from something basic. You do some adjustments, then you go deeper to that extent where you start thinking it's too much. That's probably it. Next question. Are there performance considerations or limitations when running ArchUnit on extensive code base? Well, I think we covered it on the slide with performance benchmark. So I think performance is not a problem for that. And one more question that I see is, are there specific CI/CD tools or pipelines that ArchUnit works particularly well with? Well, I haven't investigated it deeply, but in my project, it runs together with unit tests. So basically, it's just a phase of Maven execution, for example, and I think you don't really need uh, to dive deep in the CI/CD tools. You can just add it to your unit tests, and it will work pretty well. I hope I answered the questions. If there are some further questions based on my answers, please.
Yeah, I think it's a wrap. I think we covered everything that the audience asked. Thank you once again for this presentation. And so we will have the recording and share it with you. And if you have any other questions, you can always send us email and we will ask our speaker and get back to you with the updates. Yeah, I think that's all from our side. Thank you once again. Thank you everyone for coming today. Wishing you the best during the New Year celebration and the Christmas celebration. And we will see you next year on our events in 2025. Have a great ending of your day and bye.
Thank you everyone for